Listen, something that you might have missed. Why do we need to know Simpson's diversity index? All right, it's on this slide. The slide's going to Teams, but I'm going to talk you through it quickly. It lets us compare sites, site A and site B, in terms of biodiversity. I'm expecting that you know what biodiversity is. All right, if you don't, go and find out. It gives us an understanding of the probability of a species being found at a location. How likely is it that I'm going to find this species here? All right? It informs us as to how well a place can tolerate a natural disaster. Okay? How well can a place manage if there's a fire, if there's a flood, if there's a disease? How well can that area survive? And generally speaking, all right, it's a decimal number between 0 and 1. If you're calculating Simpsons as a number that's 146, like somebody did in the test, then you're not really understanding what's going on. Okay? So, all SDIs are that, between 0 and 1. Check. High numbers are good for biodiversity. 0.9 is great. It means you're in a really biodiverse area. 0.1, you're not in a biodiverse area. Okay? Low values of SDI show us that you can't withstand an issue. If it's a low value, you won't tolerate floods, you won't tolerate famine, you won't tolerate disease. Higher values mean it's more likely that there'll still be living things in that area if some nasty negative impact, natural or man-made, happens. Okay? It can be expressed as a percentage. You could write 0.45 as 45%. Okay? You can call it high, 0.6 and above. You can call it low, 0.4 and below. You can call it moderate, anywhere in the middle. They're terms that we use arbitrarily, a little bit, but they're definitely terms that we use. Everyone good? Okay. Finally, SDI as a percentage tells us the probability of finding two organisms that are different in the area if we do another survey. There was a question a bit like that on your exam, and it says, what's the likelihood of, if I did another survey, of finding two creatures, two plants, that are different within my quadrats? And all you say is, well, actually, if SDI was 55% or 0.55, you say there's a 55% chance that they're going to be different. Okay? There's a 55% chance that I'm going to find two different things, plant A and plant B. If there's a high biodiversity, your chance is higher to find those two different things. If there's a low biodiversity, it's much less likely that within a quadrat you'll find those two different things, right? So you just convert Simpsons as a decimal into a percentage and you can make that statement.